Welcome to Ganitika.com. This is a website for mathematics lovers, learners, and leaders. In this video, I'll be explaining about inverse trigonometric functions, their graphs, domains, and ranges. You can see the explanation of this in Trigonometry Part 2 chapter in Ganitika.com. Let's first understand what is sine inverse of x. A sine x curve will look like this. So the domain of sine x is negative infinity to infinity, which is all real numbers, whereas the range is negative 1 to 1, and this is our sine x curve. In order to find the inverse of a function, we will swap the x-axis and y-axis. So x-axis becomes the y-axis and y-axis becomes the x-axis, and then we draw the same graph like this. Then this becomes the inverse function of the sine curve. But if we draw a vertical line like this, we can see that it intersects the curve at multiple points, which means the graph fails the vertical line test. Therefore, this is not a function. In order to make this into a function, we will restrict either the domain or range. In this case, we will take this part so that the sine x curve would look like this, and so we have domain as negative 1 to 1, but the range is restricted to negative pi over 2 to pi over 2. If we consider this section alone as inverse of sine x, then we can see that it satisfies the vertical line test. Sine inverse x is written as sine to the power of minus 1x or arc sine x. Considering this graph, we know that this fails the vertical line test, and we have taken this graph as our sine inverse graph, which is negative pi over 2 to pi over 2. In this restricted range, sine inverse of 0.5 would be 30 degrees or pi over 6 radians. This is in the range negative pi over 2 to pi over 2, which is negative 90 to 90 degrees. Instead of considering this range, we could have considered this as sine inverse of x because this satisfies the vertical line test, and the restricted range would be pi over 2 to 3 pi over 2. So the other option for sine inverse of 0.5 in this range is 150 degrees, which is lying between pi over 2 to and 3 pi over 2 as its range. And further, we can also consider this as our sine inverse of x with the range as 3 pi over 2 to 5 pi over 2 and so on. We can consider sine inverse of x at multiple ranges like this, which means on the coordinate axis, if it is in the first range, it is 30 degrees. The second type of range, it's 150 degrees. And the third range would be 390 degrees and so on. So depending on the range that you have considered for sine inverse of x, you will get the value for the degree. But this value, which is negative pi over 2 to pi over 2, is called the principal range of sine inverse of x, and we usually deal with this range for sine inverse of x. Unless and otherwise specified, we do not consider the other ranges. So a function sine inverse of x has the range negative pi over 2 to pi over 2, both inclusive. And this is called the principal range for sine inverse of x. Now let's consider inverse of cos x. A cos x curve looks like this. The domain of cos x is negative infinity to infinity, and the range is negative 1 to 1 as we had in sin x. For finding the inverse of this graph, we swap the x and y axis and change the graph like this, so that you can see that the x axis contains negative 1 to 1 and y axis has all the real numbers. Again, the vertical line test fails here. Therefore, we will cut the graph only in this part, and we will call this as cos inverse of x graph. So you can see that the domain of this graph is negative 1 to 1 and the range is 0 to pi. Therefore, cos inverse of x has domain negative 1 to 1, whereas the restricted range is from 0 to pi, both inclusive. You can also write cos inverse of x as arc cos x or cos to the power of minus 1x. In the same way as we did for sine inverse of x, we could have considered different ranges for the curve. For example, at this point, cos inverse of 0.5 would be 60 degrees, which is in the range 0 to pi. Whereas if I consider this part of the graph, then the domain is minus 1 to 1, but the range is going to be pi to 2 pi and so on. And this would be the range from 2 pi to 3 pi and so on. And if you consider this on the coordinate axis, it's 60, 240 and 420, and it keeps going as you change your range. Therefore, 0 to pi is called the principal range of cos inverse of x. So if we talk about f of x as cos inverse of x, then the range considered is 0 to pi, both inclusive. Now let's move on to inverse of tan x. This is the graph of tan x. You can see that there are asymptotes at every odd multiples of pi over 2. Therefore, the domain will be all real numbers minus odd multiples of pi over 2. And the range is all real numbers. Graphing the inverse of this, we will get a graph like this, and you can clearly see that this fails the vertical line test. Therefore, we will restrict the domain from negative pi over 2 to pi over 2, and you can notice that negative pi over 2 there is a horizontal asymptote, and at pi over 2 again there is a horizontal asymptote. Therefore, the graph of tan inverse of x looks like this between negative pi over 2 to pi over 2, and the domain is all real numbers, and tan inverse of x is written either like this or arc tan x. So considering the same way as we did for sine or cos x, other ranges could be pi over 2 to 3 pi over 2, 3 pi over 2 to 5 pi over 2, etc. Note that the endpoints are not included because at every odd multiples of pi over 2 we have horizontal asymptote here. And the principal range for tan inverse of x is negative pi over 2 to pi over 2. Unless otherwise stated, your range should be minus pi over 2 to pi over 2 for tan inverse of x. Let's summarize what we just learned. Sine inverse of x, domain was minus 1 to 1, both inclusive, and the range was minus pi over 2 to pi over 2, both inclusive. Cos inverse of x, negative 1 to 1, both inclusive, and principal range is 0 to pi, both inclusive. Whereas for tan inverse of x, it's all real numbers is the domain, but the principal range is negative pi over 2 to pi over 2. The endpoints are not included in this range. Now let's consider this particular property of composition of functions with its inverse. We know that for any function f of x, f composition f inverse is equal to x, and f inverse composition f is also equal to x. But for trigonometric functions, there is going to be restriction on the value of x that can be applied here. Say for example, we want to consider sine of sine inverse of x to be equal to x. In this case, the x here should be the domain of sine inverse of x, and the x here should be the range of sine of x. Accordingly, these x's can be in these intervals, which means this is only possible when x is in this interval minus 1 to 1, both inclusive. Consider this composition. Sine inverse of sine of x is equal to x. In this case, the x here is the domain of sine of x, which is all real numbers, whereas the x here is in the range of sine inverse of x, which is minus pi over 2 to pi over 2. Therefore, this is only possible in the smaller interval, which is negative pi over 2 to pi over 2, both inclusive. Remember, pi over 2 is 1.5. Therefore, this interval is approximately equal to negative 1.5 to 1.5. So both of them can occur simultaneously only when x is in the smaller range of these two intervals, which is negative 1 to 1. Consider this graph. This is y equal to x, and this is sine inverse of sine of x, and this is sine of sine inverse of x. You can see that all the three of them coincide only in this small region, which is between negative 1 to 1. Now let's consider this for cos. Cos of cos inverse of x. The x here is the domain of cos inverse, and x on the right side is the range of cos x. Therefore, the intervals should be like this, which means this is possible only when the x is in the domain negative 1 to 1. For the other type, this is possible when x is in the range 0 to pi, because 0 to pi is a smaller interval than the real numbers. Therefore, we should consider the x in 0 to pi interval so that this is satisfied. So both of them could occur simultaneously in the smaller interval, which is 0 to 1. So minus 1 to 1 and 0 to pi, pi is 1.5. So combining these two intervals, the common interval is 0 to 1. So on the graph, this is y equal to x. This is cos inverse of cos of x. This is cos of cos inverse of x. All these three coincide between these 2 points, which is 0 to 1. Let's do the same for tan. Tan of tan inverse of x. X is in all real numbers because the domain of tan inverse of x is all real numbers and the range of tan of x is all real numbers. Therefore, it's going to be all real numbers for this condition to be satisfied. Whereas tan inverse of tan of x is possible only in the range of tan inverse of x, which is negative pi over 2 to pi over 2. Combining them together, all the three are possible only when x is in the range negative pi over 2 to pi over 2, both not inclusive. So the graph of tan inverse of x is here. This is the graph of y equal to x. And then this is the graph of tan inverse of tan of x. You can see where they coincide is between negative 1.5 to 1.5, which is negative pi over 2 to pi over 2. Thanks for watching. Visit Ganitika.com for more information on inverse trigonometric functions under Trigonometry Part 2 chapter. Thank you. Bye-bye.